Today we're going to do a quick review of graphing quadratic equations. And our goal here is to show graphs and discuss their characteristics, and to graph the equation 2x squared minus 6x equals negative 4. So first, remember that this is considered the parent function for quadratic equations. It's just a simple y equals x squared, has a parabolic shape opening up, starting at the origin. Here is the negative y equals negative x squared, same parabolic shape, starting at the origin. However, this time it opens down. Here we have 2x squared and then negative 2x squared, and again same parabolic shape. However, the difference this time is the functions are a little bit narrower. The graphs are a little narrower. So next, I want to dissect this graph a little bit. The graph is of y equals x squared plus 10x plus 25. Again, same parabolic shape, which is governed by the x squared. And some of the points of interest are the vertex, which is in this case the lowest, the smallest, the minimum point. In the case of the negative equations, this point, the vertex, is actually the maximum. Another point of interest is the line of symmetry. It is a line that goes through the vertex at the x coordinate, and everything on the right is the same distance away from the line of symmetry as everything on the left. So parabolas are symmetric. And the y-intercept. Remember, the y-intercept is the point where the graph crosses the y-axis, where the value of x is 0. Please feel free to stop the video at any time so you can catch up with your notes. I just want to quickly share with you the calculations to find these points. I started with the vertex x value and the line of symmetry, which are the same points, and I used negative b over 2a, substituting my values, and so x equals negative 5, which is right here. Then I wanted the y-intercept, so I substituted x equals 0, and my result was y equals 25, which is the point I graphed up here. And lastly, I picked another point, and I chose somewhere in between here, and that was negative 2. And my calculations ended with y equals 9. So here was the vertex, here's y equals 9, here's the y-intercept, and then directly on the opposite side of the line of symmetry, the same distance away, I can choose other points and draw my parabola. Okay, now we're going to graph together the function 2x squared minus 6x equals negative 4. My first step is to put it in standard form by adding 4 to both sides. So these are the 4 values I want to find: the line of symmetry and the x value of the vertex, which are one and the same points, the y value of the vertex, the y-intercept, and one more point. So to find the line of symmetry, again, I'm using negative b over 2a, and I substitute my values. So the line of symmetry goes through 1.5. So let's just go ahead and draw that. So here's my line of symmetry. Now, the vertex is going to be along this line somewhere, but I have to find where exactly on the y-axis this point lies. So I'm going to take the value of x equals 1.5 and substitute it into my original equation. And 2 times 1.5 squared minus 6 times 1.5 plus 4 equals negative 0.5. So the point of the vertex, the coordinates, is 1.5 for x and negative 0.5 for y. So here we have our point right here, our vertex. Now this is, because this is a positive parabola, this will be the minimum point. All right, the y-intercept I want to find next. So the y-intercept is going to be where x is 0. So y is equal to 4, and these are the coordinates. 1, 2, 3, 4. There's my y-intercept. And one last point. Oh, let's do this. The point on the other side of the line of symmetry is right there. So now I know I want another point a little bit further out. So I'm going to choose 4. I'm going to let x equal 4, and so I just substitute it. So y is equal to 12. So here's my last point. So here's 4, 5, 6, 7, 8, 9, 10, 11, 12. And directly on the other side, the same distance away. And now we can draw our parabola.